Mother's a janitor here. Probably snuck in while Mama was mopping floors. Dr. Gregory Sullivan's voice cut through McCosh Hall like a knife. Department chair at Princeton University for 15 years, tenure secured, reputation untouchable. He held Patricia Ingram's note card between two fingers like examining trash, squinted at it with theatrical disgust. 200 years, the greatest minds in mathematics couldn't crack the Goldstein conjecture. But this black girl from the projects thinks we should stop everything and hear her brilliant insights. He paused, let the words hang in the air. 800 people packed into the auditorium, another 50,000 watching the live stream, phones out, recording everything. This is what happens when we lower standards. Sullivan ripped the note card in half, let the pieces flutter to the floor, ground them under his Italian leather shoe, turned his back completely on the 15-year-old girl standing in the back row. Patricia Ingram stood frozen. Sophomore at Newark Central High School, 90-minute bus ride each way, daughter of a cleaning woman who made $43.50 per shift after taxes. Her mother was watching from the side door in her janitorial uniform, tears already streaming down her face. What Sullivan did next would cost him everything he'd spent 25 years building. But what he didn't know was that Patricia Ingram had been waiting her whole life for someone to tell her she wasn't smart enough, and this time, she wasn't going to stay quiet. Comment where you're listening from, subscribe to channel, let me tell you who Patricia Ingram really was. 15 years old, born in University Hospital, Newark on a Tuesday morning in January 2009. Her mother, Diane Ingram, was 19 years old. Single. Scared, but determined. Diane had dreams once, got accepted to Rutgers, full scholarship, wanted to be a teacher, stand in front of classrooms, shape young minds, make a difference. Then her own mother got sick, stage 4 cancer. Medical bills piled up faster than Diane could count. 50,000, 100,000, more. Insurance covered some, not enough, never enough. Someone had to work, someone had to pay. Diane's younger siblings were still in high school. Her father had left years before. It was just her. So Diane deferred her admission, took a job cleaning houses, rich people's houses in Short Hills, West Orange, Montclair, big houses with marble floors and crystal chandeliers. Houses that cost more than Diane would make in 10 lifetimes. She scrubbed toilets, vacuumed carpets, dusted furniture, invisible work done by invisible people. Her mother died 6 months later anyway. By then, Diane had missed her enrollment window, lost the scholarship. The dream of teaching dried up like paint on a forgotten canvas. But here's what nobody knew. Diane Ingram was brilliant, not just smart, brilliant. She'd scored in the 99th percentile on her SATs, had written essays that made her English teachers cry, could solve complex mathematical equations in her head while other students struggled with calculators. None of that mattered when you were 19, and poor and black, and the system needed you to clean instead of think. By age 3, Patricia could read. Not simple picture books. Chapter books. By age 5, she was reading her mother's old college textbooks. Calculus, physics, chemistry. Words she couldn't pronounce, but concepts she somehow understood. Diane would find her daughter at 2 a.m, flashlight under the covers, reading about quantum mechanics or differential equations. "Baby, you should be sleeping." "I can't, Mama. I need to understand how wave functions collapse." She was 7 years old. Newark Central High School had no advanced mathematics program, no calculus, no statistics, no computer science. The newest textbook was from 2009, the year Patricia was born. Budget cuts. They always hit the poor schools first. The black schools. The schools where kids like Patricia were supposed to accept their limitations and be grateful for whatever scraps they received. Patricia taught herself, library books, YouTube videos at 3 in the morning, MIT OpenCourseWare on her phone during lunch break, Khan Academy, Coursera, any free resource she could find. By freshman year, she'd taught herself calculus, linear algebra, differential equations, number theory. Her teachers didn't notice. They saw a quiet black girl who turned in her basic algebra homework on time. Got A's without trying. Never caused trouble. Never asked for more than what was offered. Good enough for Newark. Not Princeton material. That's what her guidance counselor told her when she asked about college applications. Patricia, you're a good student. Maybe consider community college. Rutgers, Newark, if you're lucky. But places like Princeton? That's for a different kind of student. She meant white. She meant rich. She meant kids who didn't take 90-minute bus rides from the projects. But 3 months ago, everything changed. Patricia's mother worked the night shift at Princeton. 6 p.m. to 2 a.m., cleaning classrooms, emptying trash cans, mopping floors that students walked on without seeing, without thinking about who cleaned them. Patricia often came with her. Did homework in empty lecture halls. Nobody noticed a quiet black girl with a backpack in the corner. Security guards saw Diane's badge, assumed Patricia was visiting, never asked questions. One night, Patricia wandered into a calculus lecture. Just curious. The professor was explaining derivatives. Patricia sat in the back, listened. The professor made an error on the board. Small thing. Most students didn't catch it. Patricia raised her hand. The professor looked surprised. Called on her anyway. There's an error in line 3. The chain rule application is incorrect. The professor squinted at the board, checked his work, realized she was right, corrected it. Thank you. Are you registered for this class? No, sir. Just visiting. He nodded. Continued teaching. Patricia came back the next week, then the next. Attended 17 Princeton lectures that semester. Advanced calculus, number theory, abstract algebra, real analysis. Never got caught. Never got questioned. Just a ghost in the back row, absorbing knowledge that wasn't meant for girls like her. Because the more Patricia learned, the more she started to see things other people missed. 6 months ago, she discovered the Goldstein conjecture. It was mentioned in passing during a number theory lecture. Professor mentioned it as an example of an unsolvable problem, something mathematicians had tried to crack for 200 years. Over 60 published proofs. Every single one contained fatal errors. Most professionals now believed it simply couldn't be solved with current mathematical tools. Patricia went home that night and looked it up. Found the original paper, written in 1823 by German mathematician Friedrich Goldstein. The problem was about prime numbers, specifically whether prime numbers follow a predictable pattern in polynomial sequences, or whether we can prove that no such pattern exists. The paper was in German, not fluent, just enough. 6 months of Duolingo, YouTube tutorials, German-English dictionaries, grammar guides. She went to Princeton's rare books room, 3rd floor, shelf M43, used her mother's employee ID to access the archives, found the original manuscript, handwritten, 1823. Delicate pages yellowed with age, and she noticed something nobody else had seen. Page 31. Goldstein had crossed out a paragraph heavily. Black ink. Intentional. Hiding something. Patricia held it to the light. Could barely make out the words underneath. Latin. 1 sentence. Quod probare non potest, demonstrare potest. What cannot be proven can be demonstrated. Her heart stopped. Goldstein knew. 200 years ago, he knew. The proof was impossible with the mathematics of his era, but he was leaving a hint, a breadcrumb, for someone who would come later with better tools. Patricia ran home that night, started working, filled 17 notebooks over 6 months, tested ideas, hit dead ends, started over, tried different approaches. The problem everyone was trying to solve. Find the pattern in prime number distribution. But Goldstein's original question wasn't about finding the pattern. It was about proving whether a pattern was even possible to find with current mathematical methods. Completely different question. Everyone had been answering the wrong question for 200 years. Patricia thought she found a way in, a door nobody else had seen. A framework for proving that the unpredictability of prime gaps wasn't random chaos, but structured complexity beyond current analytical tools. She called it the dual space operator, a mathematical bridge between discrete and continuous analysis at the exact boundary point where both exist simultaneously. Revolutionary. If it worked. But who would believe a 15-year-old black girl from Newark? Who would even listen? Then Patricia saw the poster. Public Math Night at Princeton. Free admission. Open Q&A session. She thought maybe she could ask one question. Get one piece of validation. Just a crumb. She wrote her question on a note card, waited in line with other attendees, submitted it to the moderator. Dr. Gregory Sullivan read it during the Q&A session. Read her name, Patricia Ingram. Looked at her seat. Back row. Looked at her clothes. Target clearance rack. Looked at her face. Black. And decided to make an example. Sullivan held the note card up for everyone to see. This question is about the Goldstein conjecture, from Patricia Ingram. He scanned the room. Found her. Made eye contact. Stand up, Miss Ingram. Patricia stood, legs shaking. You believe the Goldstein conjecture can be solved? Yes, sir. Laughter rippled through the crowd. Not friendly, mocking. Sullivan smiled. Not warm, predatory. Tell me, Miss Ingram, where do you attend school? Newark Central High School, sir. I see. And Newark Central has an advanced mathematics program? No, sir. But you've taken calculus, linear algebra, real analysis? I taught myself, sir. More laughter, louder this time. Sullivan's smile widened. You taught yourself. How admirable. He looked at the audience, playing to them now. Ladies and gentlemen, this is what happens when we tell children that feelings are more important than facts. When we lower standards in the name of inclusion, when we confuse confidence with competence. He turned back to Patricia, voice dripping with condescension. Miss Ingram, the Goldstein conjecture has defeated Gauss, Euler, Riemann, the greatest mathematical minds in history, men who dedicated their entire lives to number theory. And you think you've solved it? I think I found an approach nobody's tried before, sir. An approach? Sullivan nodded slowly. Let me guess. You read a Wikipedia article, watched some YouTube videos, and now you think you understand mathematics at a level that eluded doctoral researchers for 2 centuries. Patricia's voice was barely audible. I read the original German manuscript, sir. The room went quiet. Sullivan's smile faltered. Just for a second. Then recovered. You read German now. How versatile. I taught myself German to read Goldstein's original paper, sir. The 1823 handwritten version. 3rd floor rare books room. Shelf M43. Sullivan's jaw tightened. That was too specific. Too detailed. He changed tactics. Security, please escort this young lady out. She's disrupting a private academic event. 2 security guards started moving toward Patricia's row. Then a voice cut through the room. Gregory, she submitted a question during open Q&A. You can't remove her for asking a question. Professor Raymond Clark, visiting scholar from Stanford, one of only 3 black mathematics professors in the Ivy League. He'd been watching from the side panel. Sullivan's face reddened. Raymond, this isn't a question. This is a disruption. She asked about the Goldstein conjecture. You're the one who turned it into a spectacle. The room buzzed. people whispering, phones recording everything. Sullivan saw he was losing control, decided to crush her completely. Fine. Miss Ingram, you're so confident? Come up here. Explain your revolutionary approach to everyone. You have 10 minutes. Professor Clark stood up. Gregory, that's not fair. She's 15. She hasn't prepared a presentation. She came here to challenge 200 years of mathematics. Let her challenge it. 10 minutes. If she's right, I'll publicly apologize. He paused. Let it sink in. But when she fails, she leaves permanently, and she writes a public letter apologizing for wasting everyone's time. Patricia's mother stepped forward from the side door, still in her cleaning uniform, gloves tucked in her belt. Baby, you don't have to do this. Patricia looked at her mother, at Sullivan's smug face, at 800 people waiting for her to fail, at 50,000 more watching online. She thought about her mother. 30 years cleaning buildings. Invisible. Told she didn't matter. She thought about every black girl who would watch this video, who would see someone like them try and fail publicly, who would learn to keep their heads down. She walked toward the stage. I accept. The room erupted. Not laughter this time. Anticipation. Phones up. Recording. Sullivan handed her a marker. Pointed to the massive whiteboard. 10 minutes. Starting now. A countdown appeared on the screen. 10 short. The clock started ticking. Patricia stood at the whiteboard, marker in hand, 800 people staring. The countdown read 9:45. Her hand shook. She wrote the first line. The Goldstein conjecture. Original question, 1823. Turned to face the audience. Can we prove that the distribution of prime numbers in polynomial sequences is fundamentally unpredictable? She wrote again, faster now. Every attempt for 200 years tried to find the pattern, but Goldstein wasn't asking about the pattern. He was asking if we could prove no pattern exists that we can see with our current tools. 9:20, remaining. Sullivan crossed his arms. You're stalling. That's not mathematics. That's philosophy. Patricia ignored him, kept writing. Obstacle 1. The philosophical trap. If you spend 200 years looking for something that isn't there, you'll never find it. But you also can't prove it isn't there unless you change what you're looking for. Dr. James Mitchell, guest panelist from MIT, leaned forward. Interested. She's talking about Gödel's approach, incompleteness theory. Patricia nodded. Yes, sir. Kurt Gödel proved in 1931 that some things cannot be proven inside a system. You have to step outside the system. Goldstein's question is the same. We can't prove unpredictability from inside traditional number theory. We need a new framework. 8:50 remaining. She drew 2 circles on the board. One labeled local behavior, one labeled long-term behavior. Obstacle 2, the density paradox. Prime gaps look random, but random doesn't mean structureless. It means the structure is too complex for our current tools to see. She drew an arrow between the circles. Every prior attempt used continuous mathematics, calculus, analysis, integration, but prime numbers are discrete, individual, separate. You can't use smooth continuous tools to study discrete objects. That's like trying to count atoms with a ruler. 8:10 remaining. A student in the 3rd row raised his hand. Thomas Ellis, senior, Sullivan's research assistant. Miss Ingram, that's a nice metaphor. But where's the actual mathematics? You're just describing the problem everyone already knows. Patricia looked at him, then back at the board. Obstacle 3. The false choice. Traditional analysis forces you to pick. Do you study local behavior or long-term behavior, discrete methods or continuous methods? But Goldstein's conjecture lives in the space between. 7:30 remaining. She wrote faster, more confident. At the boundary between local and long-term, there's a transition point, A single mathematical moment where both exist simultaneously. That's not a weakness. That's the door. She drew a new symbol, a bridge between her two circles. I call this a dual space operator. It lets you analyze both discrete and continuous properties at the exact same instant, at the boundary. Mitchell pulled out his phone, started calculating. Sullivan's jaw tightened. You can't just invent new operators. That's not how mathematics works. 7 torwas remaining. Patricia turned to him, voice steady now. Sir, when Leibniz invented calculus, he invented new operators. When Fourier studied heat, he invented new transforms. Every breakthrough required inventing something new. You're not Leibniz. You're not Fourier. You're a child. Then challenge my mathematics, sir, not my age. The room reacted. Whispers. Someone clapped once, stopped. 6:40 remaining. Thomas Ellis stood again. Dr. Sullivan, I think I see a problem. Look at her diagram. She's combining asymptotic behavior with local density, but those are fundamentally incompatible. That's a freshman mistake. Several people nodded. Sullivan smiled. Miss Ingram, Mr. Ellis has a point. You've conflated two different mathematical domains. They can't be analyzed together. Patricia studied her board for 5 seconds. Didn't speak. Then she circled a section. Mr. Ellis, you're right that asymptotic and local are different. But look closer. I'm not conflating them. I'm analyzing their boundary. 6 wakonser remaining. She drew a new line. At the transition point, there's one infinitely brief moment where a sequence is neither fully local nor fully asymptotic. It's both. Traditional math forces you to pick one. My operator captures that single instant. She wrote a new expression. Not an equation, a description. If you measure the gap pattern at position n, that's local. If you measure the trend as n approaches infinity, that's asymptotic. But at the exact boundary for one mathematical instant, the local gap equals the long-term trend. That instant exists, and it's calculable. Mitchell looked up from his phone. Wait, she's describing a dual limit operator. I've never seen this application before, but the boundary condition she's describing is mathematically valid. Sullivan stood, walked to the board, studied it. 5:20 remaining. He pointed to her operator. This is speculation. You haven't proven this boundary exists. Not in 10 minutes, no. No, sir. But I can show why it must exist. She wrote quickly. 3 lines of logic. Prime numbers are discrete, sequences are discrete, but distributions are continuous functions. The only way a discrete object can have a continuous distribution is if there's a boundary where discrete becomes continuous. That boundary must exist, and my operator describes it. 5 form. Remaining. Dr. Sarah Bennett, the third panelist, spoke for the first time. That's actually a compelling argument. She's using proof by necessity. Sullivan's face darkened. A framework is not a proof. She hasn't actually solved anything. 4:40. Remaining. Patricia set down the marker, faced him directly. Sir, you're right. I haven't shown you the complete proof. But I've shown you something nobody has seen in 200 years. A door, a way forward. And if you give me more time, I can walk through it. The countdown hit 4:30. Professor Clark stood from the audience. I move that we allow Miss Ingram to present a complete proof. Not tonight. Give her 1 week. Let her prepare properly, then bring her back. Let the panel evaluate it fully. Sullivan turned to Clark. Voice ice cold. Raymond, you can't be serious. We don't run a charity here. I'm completely serious. She's demonstrated a novel approach. She deserves a fair evaluation. She's demonstrated nothing. She drew some circles and invented a fancy name. Any undergraduate could do that. Mitchell stood. Gregory, I've been doing number theory for 25 years. Her boundary operator concept is sound. At minimum, it's worth investigating. The room buzzed. Students whispering, donors watching, cameras recording everything. Sullivan saw he was cornered. If he refused now, he looked afraid, like he was blocking her because he knew she might be right. He forced a smile. Fine, 1 week. He walked to the microphone, addressed the room like a prosecutor. Miss Ingram, you'll present a complete proof, not a framework, not a philosophy lecture, a full, rigorous, verifiable proof of the Goldstein conjecture. Patricia's heart pounded. Thank you, sir. Don't thank me yet. There are conditions. 1. The proof must be complete, every step shown, every assumption justified, no hand-waving, no appeals to future work. 2. She presents it here in this hall before an expanded panel of 5 judges, 2 from Princeton, 2 external experts, and 1 neutral chair. 3. If even 1 judge finds a logical flaw, the proof is rejected, and Miss Ingram agrees to never again claim she solved it. Clark interrupted. Gregory, that's excessive. Even published proofs get revised. These are the standards we hold for anyone claiming to solve a 200-year-old problem. Or do you think we should lower them just for her? The trap was obvious. Patricia saw it. Clark saw it. But there was no way out. Dean Margaret Foster stepped forward. She'd been watching from the side. Dr. Sullivan, I'll chair the panel, and I'll ensure the evaluation is fair. Sullivan's smile didn't reach his eyes. Of course, Margaret. Completely fair. He turned back to Patricia. So, Miss Ingram, do you accept these terms? 1 week. Complete proof. 5 judges. 1 flaw, and you're done. Patricia looked at her mother. Diane's face was streaked with tears. She was shaking her head slightly. Don't do it, baby. Don't let them hurt you again. Patricia looked at Clark. He nodded once. Encouraging, but honest. This will be brutal. She looked at the countdown clock. Still frozen at 4:30. The moment she stopped explaining and started defending herself. I accept. The room erupted. Half the people thought she was brave. Half thought she was delusional. Everyone thought this would be spectacular to watch. Sullivan extended his hand. Patricia shook it. His grip was crushing. He leaned in. Whispered so only she could hear. You just ended your mother's career too. When you fail, everyone will know the janitor's kid wasted Princeton's time. She'll be gone within a month. Patricia's hand trembled, but she didn't let go, didn't look away. Dean Foster announced the date. Friday, 1 week from tonight, 7 p.m., same location. We'll open it to the public again and live stream it. The moderator dismissed the crowd. Within 20 minutes, the video clips were everywhere. Teen challenges Princeton professor on 200-year math problem. 15-year-old girl versus Ivy League mathematics? Janitor's daughter claims she solved the impossible. By midnight, the main clip had 500,000 views. Comments split 50-50. She's incredibly brave. Fine. She's incredibly stupid. This is what courage looks like. This is what arrogance looks like. I hope she destroys him. I hope he destroys her. People taking sides. Mathematics forums exploding with debate. Is this possible? Can a teenager actually do this? Most professional mathematicians said no. Politely, they admired her courage. But the math doesn't lie. 200 years of failure means something. A few said, maybe. Very quietly. Because if she's right and they dismissed her, they'll look foolish forever. Patricia got home at 11 p.m. Their apartment was 40 minutes by bus from Princeton. 1 bedroom. She slept on the couch. Her mother sat beside her, held her hand. Baby, you don't have to do this. We can move, find another job. You can go to a different school. Patricia shook her head. Mama, if I don't do this, then every girl like me will keep getting treated like I got treated tonight. Someone has to show them we're not stupid. You're 15, Patricia. This isn't your job. Then whose job is it? Diane had no answer. Patricia opened her notebook. 7 days, 168 hours. She had half the proof done. The other half was still missing pieces. She started writing. Somewhere across town, Sullivan sat in his office. Smiling, he'd already chosen his 2 external experts. Both were his former students. Both owed him their careers. The fix was in. Day 1, Monday morning. Patricia didn't go to school. Her mind screamed with equations. Her mother called her in sick, went to work. Patricia had the apartment alone. She spread 17 notebooks across the floor, 6 months of work, every dead end, every breakthrough. The core problem was clear. She needed to prove the boundary exists, the moment where discrete becomes continuous, where local becomes asymptotic. But frameworks don't win. Proof wins. She worked until 3 a.m., slept for 2 hours. Continued. Day 2, Tuesday. Maya Richardson showed up, her best friend, holding food. You look like death. Patricia barely looked up. I'm fine. When did you last eat? Patricia couldn't remember. Maya made her eat, sat across from her. Explain it to me. Maya, you wouldn't understand. Then make me understand. Pretend I'm 5. Patricia sighed, but explaining it simply revealed gaps in her logic, places where she assumed things she hadn't proven. Maya couldn't check the math, but she could ask, how did you get from this step to that step? 3 times Patricia realized she didn't have a good answer. 3 holes. She stayed up until 5 a.m. fixing them. Day 3, Wednesday. Patricia went to Princeton Library, needed the original Goldstein papers, including damaged sections. She used her mother's employee ID for the rare books room. The librarian recognized her from the video. You're that girl. The librarian smiled. 3rd floor, take your time. Patricia photographed every page. Margins, crossed out sections, faded parts. She noticed something. Page 31. Goldstein crossed out a paragraph heavily. She held it to the light, barely made out words underneath. Latin, 1 sentence. Quod probare non potest, demonstrare potest. What cannot be proven can be demonstrated. Her heart stopped. Goldstein knew. 200 years ago, the proof was impossible with his era's mathematics. He left a path for someone with better tools. Patricia ran home, rewrote her entire approach. Day 4, Thursday, halfway through, Patricia's proof was 60 pages, growing. Professor Clark knocked on her door. They walked to a park. He handed her an envelope. The 2 external judges Sullivan picked. Patricia opened it. Dr. Harold Brennan, Dr. Elizabeth Marsh. They're both Sullivan's former students. Both got positions through his recommendations. Both have publicly opposed diversity initiatives. Patricia's stomach sank. The panel is rigged. 3 votes against you before you start. You need perfect votes from Mitchell, Bennett, and Foster. 1 mistake, and you lose. So I can't make mistakes. Nobody's perfect, Patricia. Even correct proofs have small errors. But Sullivan won't allow revision. 1 flaw, and he rejects everything. So I already lost. No. But you need to understand what you're walking into. This isn't about mathematics. It's about Sullivan protecting his reputation. Clark stood. Make your proof perfect, not just correct. Perfect. He left. Patricia sat on the bench until dark. Day 5. Friday. 72 hours left. Patricia had slept 10 hours total all week. Her phone buzzed. Unknown number. Miss Ingram? Thomas Ellis. Dr. Sullivan wants to help you. He has his personal research notes on Goldstein. 30 years of work. No strings attached. Patricia knew this was poison. But what if there's something useful? She responded. Where? An hour later, Thomas met her, handed her a USB drive. She went home, plugged it in. 200 pages. Dense. Technical. Brilliant. She read for 6 hours. Sullivan's approach was masterful. He got closer than anyone, but he hit the same wall everyone hits. The density paradox. Patricia followed his logic and slowly realized. This is the trap. His notes funnel thinking toward his approach. His approach leads to the standard failure point. If she follows his logic, she'll fail exactly like he did. She deleted the files, started over from her own foundation. Day 6, Saturday. 24 hours left. Patricia's proof was 93 pages. She printed it, read front to back, found 2 weak points, logic sound but not airtight. She rewrote those sections. Tighter, clearer, more verification. The proof grew to 112 pages. Her mother came home, found Patricia surrounded by paper, eyes red, hands shaking. "Baby, you need to sleep." "I can't. It's not done." "If you don't sleep, you can't think tomorrow." Diane sat beside her, took her hand. "When I was your age, I wanted to be a teacher. Got into Rutgers. But my mama got sick. Had to work. Couldn't afford school and medical bills. So I cleaned houses, then offices, then universities." Her voice cracked. "Smart doesn't matter if they decide you don't belong. I learned to be invisible, to accept what they said I was." She squeezed Patricia's hand. "But you didn't learn that. You said no. And baby, even if you're wrong about the math, you're right about that." Patricia cried. First time all week, then slept. 4 hours, deep. Day 7. Sunday. Patricia woke at noon. Proof printed. 112 pages. 3 copies bound. She tried to eat, couldn't keep it down. Maya texted. "You got this," Clark called. "Remember, perfect." 3 p.m. She took the bus. 90 minutes. Read her proof one more time. 5 p.m. arrived. The parking lot was packed. Over 1,000 people trying to get in. Security turning people away. Someone recognized her. "That's her." People stared. Some encouraging, some hostile, all curious. She walked to the side entrance, her mother's employee entrance. Security stopped her. "You can't come through here. I'm presenting tonight. Use the main entrance." Patricia walked around, waited in line. 30 minutes, finally inside. Every seat filled. People standing. Cameras everywhere. 150,000 watching the live stream. She saw Sullivan at the judges' table, smiling, confident. She saw Clark in the front row, nodding. She saw her mother in the back, hands clasped, praying. 6:45 p.m., 15 minutes. Patricia sat alone, proof on her lap. She'd done everything she could. Math was sound. Logic was airtight. But the game was rigged. 3 judges against her. She needed perfection. And nobody's perfect. 7 p.m., Dean Foster opened the session. "Welcome to this special evaluation. Miss Patricia Ingram will present her proof of the Goldstein conjecture. The panel of 5 will verify. Questions allowed throughout. Miss Ingram, you may begin." Patricia walked to the front, set down her bound proof, distributed copies to each judge. Sullivan flipped through his copy. Didn't read it, just counted pages. 112 pages. This should take a while. Patricia began, her voice shaky at first, then steadier. She walked through the framework, the philosophical reframing, the 3 obstacles, the boundary concept. 30 minutes in, she introduced the dual space operator, showed why it must exist, proved the boundary is real. Mitchell took notes, furiously. Bennett nodded along. Foster listened carefully. The 2 external judges, Brennan and Marsh, sat with arms crossed, faces blank. 1 hour in, Patricia moved to the critical section, the recursion proof, where every prior attempt failed. She explained how prime gaps behave at the boundary, how local and asymptotic merge for one calculable instant. Sullivan interrupted. Miss Ingram, on page 67, you reference a theorem by Kowalski from 1998. Kowalski's work was on elliptic curves, not prime distributions. How do you justify using it here? Patricia froze. This is the attack she feared. Sir, I'm not using Kowalski as direct proof. I'm using it as structural inspiration. On page 68, I rebuild the framework from prime axioms. It's a parallel construction. Mitchell checked page 68. She's right. It's analogous reasoning, not direct application. Sullivan's jaw tightened. It's a sloppy citation. Misleading. Foster intervened. Gregory, the citation is clear. She labels it as analogous. Continue, Miss Ingram. Patricia continued, but her confidence was shaken. Sullivan found something to attack. What else will he find? 1 hour, 30 minutes. She reached the convergence proof, the final piece. The part that proves the sequence reaches a finite limit. She explained the logic. Step by step. Careful. Precise. Brennan, one of Sullivan's picks, raised his hand. Miss Ingram, your convergence relies on lemma 9 on page 89, but I don't see lemma 9 anywhere in my copy. Patricia's blood went cold. She flipped to page 89. Blank. The page was there, but it was empty. No lemma 9. She checked her own copy. Same thing. Blank. She checked the third copy. Blank. Her heart stopped. The print shop. When she printed the final version this morning, the printer jammed at page 89. She reprinted it, but somehow the file got corrupted. Lemma 9 is missing from all 3 copies. Sullivan smiled, leaned back in his chair. Miss Ingram, without lemma 9, your entire convergence proof is unsupported. The logic fails. Do you have lemma 9 or not? Patricia stood frozen. 1,000 people watching. 150,000 online. The proof that took 7 days, that cost her sleep, sanity, everything, missing its most critical piece because of a printer malfunction. Patricia stared at the blank page 89. Her hands shook. Sullivan's voice cut through. Miss Ingram, do you have lemma 9 or not? I wrote it. I know I wrote it. The printer must have... The printer, of course. How convenient. The room murmured, people whispering, some sympathetic, most skeptical. Thomas Ellis, sitting in the 3rd row, leaned to another student, loud enough to hear. I knew it. She never had a real proof. Just smoke and mirrors. Patricia's vision blurred. 7 days. Everything gone because of a corrupted file. Dean Foster spoke. Miss Ingram, can you reproduce lemma 9 now? Sullivan interrupted. Margaret, we can't allow her to write proofs during evaluation. Either she has it or she doesn't. This is exactly why we have standards. Gregory, a missing page due to technical error is different from not having the work. Is it? Or is this a convenient excuse when she realized her logic doesn't hold? Patricia's voice, barely audible. I can prove it. Give me 20 minutes. I can write it on the board. Sullivan stood, addressed the room like a prosecutor. Ladies and gentlemen, what we're witnessing is the collapse of an unprepared student who overestimated her abilities. This is what happens when we encourage people beyond their competence, when we tell them feelings matter more than facts. He turned to Patricia. You claimed you solved a 200-year-old problem. You demanded we take you seriously. We gave you a week. We assembled a panel. We opened this to the public. And you show up with an incomplete proof, blaming the printer. His voice rose. This is insulting to mathematics, to this institution, to everyone who took you seriously. Patricia's mother stood up in the back. That's enough. She made a mistake. The file got corrupted. Give her a chance to fix it. Sullivan didn't even look at her. Mrs. Ingram, with respect, This is an academic evaluation. We don't give do-overs because someone forgot their homework. Diane's voice shook with rage. You don't respect me. You don't respect my daughter. You decided she was too stupid to matter before she wrote a single equation. I decided she was unprepared, and I was right. The room erupted, people shouting, some defending Patricia, some agreeing with Sullivan. Security moved toward the aisles. Patricia stood frozen, tears streaming down her face. Mitchell stood. Gregory, this is cruel. Give her the 20 minutes. If the lemma is sound, we continue. If not, we reject it. That's fair. Brennan shook his head. Dr. Mitchell, we have standards for a reason. You can't write proofs during evaluation. The work should be complete beforehand. Marsh agreed. If we make exceptions here, we undermine the entire process. Foster looked torn. The panel is split. We need a decision. Sullivan sat down, folded his hands. I vote we end this now. The proof is incomplete. Miss Ingram fails the evaluation, and we move on. Patricia looked at the blank page, at Sullivan's smug face, at the 1,000 people waiting for her to collapse completely. She thought about her mother. 30 years cleaning buildings, invisible, told she didn't matter. She thought about every black girl who would watch this video, who would see someone like them try and fail publicly, who would learn to keep their heads down. She thought about Maya's question. How did you get from this step to that step? And she remembered. Lemma 9 wasn't the original proof. It was the revision, the elegant version. But there was an earlier version, longer, messier. But it worked. She picked up the marker. 20 minutes. I'll reconstruct it. Sullivan laughed. You can't reconstruct a lemma you never had. Patricia turned to him, voice steady now. Clear. Sir, I don't need 20 minutes. I need 10. She started writing. The room went silent. 10 minutes. 9:59. 9:58. Patricia wrote fast. Her hand didn't shake anymore. She wrote the lemma statement first. Lemma 9, a bounded recursive prime sequence with specific gap constraints converges to a finite limit. 9 minutes 30 seconds. She wrote the proof structure. Proof by contradiction. Assume divergence. Show it violates the boundary condition. Therefore, convergence. Sullivan crossed his arms, watched, waiting for her to fail. 9 minutes. Patricia wrote the first step. Assume the sequence diverges. Then for any large value m, there exists a position n where the gap exceeds m. 8 minutes 40 seconds. She wrote faster. But the boundary condition states that at the transition point, local gap equals asymptotic trend. If local exceeds m, then asymptotic must also exceed m. Thomas Ellis whispered to another student. She's just making this up as she goes. 8 minutes. Patricia didn't hear him, didn't hear anything, just the marker on the board, just the logic unfolding. But the asymptotic trend is the average over all gaps. If one gap is arbitrarily large, the average becomes arbitrarily large. This means the sequence is unbounded. 7 minutes 30 seconds. She circled a section. Contradiction. We defined the sequence as bounded. Therefore, our assumption of divergence is false. The sequence must converge. 7 minutes. She stepped back, stared at what she wrote. Something's wrong. The logic works, but it's not airtight. There's a gap. Mitchell sees it too, leans forward. Miss Ingram, what if the large gap is balanced by many small gaps? The average could still be bounded. Patricia's heart sinks. He's right. Her proof has a hole. 6 minutes 40 seconds. 40. Sullivan smiles. And there it is. The logic fails. Miss Ingram, you've wasted enough of our time. Patricia stares at the board. Think. Think. Then she remembers. Not her proof. Goldstein's hint. Quod probare non potest, demonstrari potest. What cannot be proven can be demonstrated. She erases part of her work. Starts over. Wait. Different approach. 6 minutes. She writes new lines. Consider not individual gaps, but gap distribution density. Define density function D at position N. 5 minutes, 30 seconds. If sequence diverges, density becomes arbitrarily sparse. Gaps spread further apart, but the boundary condition requires density to stabilize at the transition point. 5 minutes. Mitchell nods slowly. She's switching from individual analysis to density analysis. That's stronger. Patricia keeps writing. Sparse density contradicts stable density. Therefore, divergence contradicts boundary existence. Since the boundary exists, the sequence must converge. 4 minutes, 20 seconds. Brennan interrupts. How do you know the boundary exists? You assumed it earlier but never proved it. Patricia doesn't stop writing. Proved it on page 43. Discrete objects with continuous distributions require a discrete to continuous boundary. Boundary existence is necessary, not assumed. 4 minutes. She writes the final line. Therefore, lemonine holds. QED. 3 minutes, 51 seconds remaining. She sets down the marker. Breathing hard. Mitchell reads it carefully, checking each step, following the logic. 30 seconds of silence. Then he nods. It's different from what she originally described. But it works. Lemonine is proven. The room erupts, half cheering, half protesting. Sullivan stands. Let me see that. He walks to the board, studies it. His face darkens. He's looking for a flaw. Anything. He can't find one. He turns to Patricia, voice cold. Voice. This is a different proof than what you claimed to have. You changed your approach mid-evaluation. Yes, sir. The original was more elegant. This one is more direct, but both are valid. Or you never had the original and improvised this when cornered. Patricia meets his eyes. Sir, does the logic hold or not? Sullivan doesn't answer, returns to his seat. Dean Foster speaks. The panel will deliberate. 30-minute recess. The judges left the room. Patricia collapsed into a chair. Her mother rushed to her, held her. Baby, you did it. You actually did it. Patricia shook her head. 3 judges already decided before I started. Mitchell and Bennett might vote yes. Foster is neutral. But Brennan, Marsh, and Sullivan will say no. I lose 3-2. 30 minutes felt like hours. Finally, the judges returned. Foster stood. The panel has reviewed Miss Ingram's proof. We have reached a preliminary conclusion. However, there is significant disagreement. Sullivan stood before she could continue. I'll be direct. Miss Ingram's work is interesting, perhaps even novel, but the Goldstein conjecture is too important to validate based on one presentation by an unproven student. I move to require external verification before accepting this as a solution. That process could take months. Until then, the conjecture remains unsolved. Clark stood from the audience. Gregory, you're changing the rules. You said if the logic holds, she succeeds. The logic holds. The logic is untested, unreviewed. One presentation is not sufficient for a 200-year-old problem. Mitchell interrupted. Actually, Gregory, I took the liberty during deliberation of sending Patricia's proof to 3 colleagues, Dr. Carter at MIT, Dr. Patel at Cambridge, Dr. Muller in Berlin, all specialists in number theory. He pulled out his phone, projected the emails on screen. First email. Dr. Carter. This is extraordinary. The boundary operator is genuine innovation. Preliminary review shows no logical errors. Second email. Dr. Patel. If this holds under full scrutiny, this is Fields medal level work. The approach is unconventional but sound. Third email. Dr. Muller. I have verified the first 70 pages. No errors found. The reasoning is novel but rigorous. Who is this student? The room exploded. Students on their feet, cheering, shouting, phones recording everything. Sullivan's face went white. Those are preliminary, not full reviews. Patricia stood, walked to the front, faced Sullivan directly. Dr. Sullivan, I have a question for you, a direct question, and I'd like an honest answer in front of everyone here. She paused. Have you read my entire proof, all 112 pages? Sullivan opened his mouth, closed it. I read the critical sections. That's not what I asked. Have you read all 112 pages? Yes or no? Silence. The entire room waiting. Sullivan's voice barely audible. No. Patricia's voice didn't waver. Then how can you claim it's invalid? How can you demand external verification when you haven't verified it yourself? She stepped closer. You decided I was wrong before I wrote a single equation. Because if I'm right, if a 15-year-old black girl from Newark solved something you couldn't, then maybe your standards aren't about excellence at all. Maybe they're about keeping people like me out. The room was absolutely silent. 1,000 people, 150,000 online. Nobody breathed. Dean Foster stood. Dr. Sullivan, do you have a mathematical objection to Miss Ingram's proof, yes or no? Sullivan looked around the room. Every eye on him. Cameras recording. His reputation on the line. He sat down slowly. No, I have no mathematical objection. Foster's voice rang clear. Then this panel accepts Miss Ingram's proof as valid pending full peer review. Miss Ingram, congratulations. You have solved the Goldstein conjecture. The room detonated. Pandemonium. Students rushing forward. Maya tackled Patricia in a hug. Clark openly crying. Diane screaming with joy. Patricia stood in the center of the chaos. Numb. She'd waited her whole life for this moment. And all she felt was tired. The celebration continued. Students mobbing Patricia, reporters pushing forward, camera flashes everywhere. Then Sullivan stood, walked toward the exit. No words, just left. 10 minutes later, Dean Foster received an email on her phone. She read it. Her face went pale. She approached Patricia, still surrounded by congratulations. Miss Ingram, I need to speak with you privately. They moved to a side room. Clark, Diane, and Maya followed. Foster showed her phone. I just received a formal letter from Dr. Sullivan. He's resigned, effective immediately, from the panel, from the department chair, from Princeton. Patricia's stomach dropped. What? I didn't want that. I just wanted... There's more. Foster pulled up another document. Read aloud. To the Princeton University Ethics Board and Dean Margaret Foster. I am writing to formally acknowledge that I allowed personal bias to compromise my professional judgment in the evaluation of Miss Patricia Ingram. My conduct was unacceptable. I request my name be removed from all future symposium materials and that Miss Ingram receive a written apology from the department. She scrolled down. Showed Patricia a second letter, addressed to her. Miss Ingram, I have spent my career believing that mathematical truth is the only truth that matters. Today, you proved a theorem I could not. More importantly, you proved that my belief in meritocracy was a shield for prejudice. I failed you as a scholar and as a human being. You earned your place through excellence I refused to see. The field is better for your contribution. I am worse for my blindness. You owe me nothing. But I owe you everything, Dr. Gregory Sullivan. Patricia read it twice, hands shaking. He didn't have to do this. Clark spoke quietly. No, but maybe that's the point. You didn't just solve an equation. You held up a mirror. Foster continued. There's one more thing. 3 major journals have already contacted us requesting first publication rights, including Annals of Mathematics, the most prestigious journal in the field. It's your choice which one. Patricia looked at her mother, at Maya, at Clark. She thought about Sullivan's letter, about his resignation, about the cost of being right. I solved a problem that took 200 years, but the real problem, the one Sullivan couldn't solve, was admitting he was wrong. Maybe that's the harder proof. 3 months later, Patricia's proof was published in Annals of Mathematics, cover story. The Goldstein conjecture solved. CNN, BBC, NPR, Al Jazeera. 15-year-old genius solves 200-year math problem. Princeton offered her early admission. Full scholarship. $50,000 per year stipend. Youngest student in program history. MIT called. Stanford called. Cambridge called. Oxford called. All wanted her. Diane Ingram quit her cleaning job. Princeton hired her as community outreach coordinator. $45,000 per year. Benefits. Respect. Sullivan was gone. Nobody knew where. Some said he was teaching at a small college in Vermont. Others said he left academia entirely. But his letter remained. Posted online. 2 million views. People debating what it means to admit you were wrong. Patricia stood in her old high school, Newark Central. The place that told her advanced math was a waste of time. She was speaking to an auditorium of students, mostly black and brown kids, kids like her. A girl in the back raised her hand. "Miss Ingram, were you always sure you were right?" Patricia smiled. "No, I was terrified I was wrong, every single day. Then how did you keep going?" "Because being scared doesn't mean you're wrong. It just means you're doing something that matters." Another student. "What if we're not smart like you?" Patricia's voice softened. "I'm not special. I just loved something enough to fight for it. You all have that in you. Find what you love. Then don't let anyone tell you you're not good enough to do it." She handed out books. Mathematics, textbooks, donated from her prize money. Every student got one. A young black girl, maybe 10 years old, opened hers, started reading, smiled. Patricia watched her, saw herself 5 years ago. She wrote on the board behind her. "What's the next impossible problem?" The students stared at it, thinking, wondering, believing maybe they could be the ones to solve it. Patricia smiled. "Who's ready to prove everyone wrong?" The room erupted, hands shooting up, voices shouting, Me, I am!" And somewhere in all that noise, the future began. Sullivan resigned. Patricia got a scholarship. Everyone calls it victory. But you know what haunts me most about this story? Before Patricia wrote a single equation, Sullivan ripped her note card. "Ground it under his shoe," said the black girl from the projects couldn't understand what the greatest minds failed for 200 years. He decided who gets called real mathematician for 15 years. Patricia taught herself German, worked 6 months, 17 notebooks. Final week, slept 10 hours total. Sullivan finally admitted, no mathematical objection, just resigned. Wrote a letter. "I allowed bias to compromise judgment. You proved my meritocracy belief was a shield for prejudice." He didn't apologize because he learned. He apologized because she forced him to see. Patricia had to be perfect under impossible pressure just to get a fair evaluation. Her mother cleaned buildings for 30 years. Invisible. Patricia almost became invisible too. How many brilliant kids right now are being dismissed? Not because they're wrong, because they don't look like someone's idea of genius. Sullivan only changed after public humiliation, after Patricia proved him wrong in front of the world. The system wasn't built for fairness, built to keep certain people out. Let me ask you something. Have you ever been told you're not smart enough? Not good enough? That your dreams are too big for someone like you? Have you ever watched someone with less skill but more privilege get opportunities you deserved? Have you ever been the only person who looks like you in a room full of people who decided you don't belong before you opened your mouth? Drop your story in the comments. Because Patricia's story isn't unique, it's universal. Share this story. Not the sanitized version the news tells, the real version, the one that shows how close Patricia came to giving up, how rigged the game was, how hard she had to fight just to be heard. Because genius doesn't require permission. Brilliance doesn't need approval. Excellence doesn't wait for the right skin color or zip code or bank account. It just requires one thing: refusing to believe you're not good enough. Sullivan spent 25 years building a career on declaring something impossible. Patricia spent 6 months proving it wasn't. Their doubts don't define your limits. Your courage does. Subscribe to channel for more stories where brilliance wins despite barriers, where the underestimated become the undeniable, where justice isn't just a word, but a destination we fight toward together. Because the next impossible problem? It's waiting for someone who refuses to accept that impossible means anything at all. Stay just, stay loud, stay free. And remember, the world tried to silence Patricia Ingram before she spoke a word. She spoke anyway. What will you refuse to stay silent about? The answer to that question might change everything.